Fairway Electric. Performance beyond competition. Hello. How are you doing? Let me hope that you're doing all right. If it is your first time on this channel and you have not yet subscribed to our channel, please subscribe and remember to give us your feedback and suggestions in comment. Thank you. Objectives of this course series are: know general PLC issues, to be able to write simple ladder logic programs, understand the operation of a PLC. Let us start our course of today of PLC. We are going to see Introduction to PLC. Let's go. PLC stands for Programmable Logic Controller. PLC is defined as microcontroller-based device that are deployed in the field, mostly in industry, to collect data from various sensors and make decision for auto control purposes. Simply, a PLC is a computer-based controller that uses inputs to monitor a process, and uses outputs to control a process using a program. Control engineering has evolved over time. In the past, humans were the main method for controlling a system. More recently, electricity has been used for control, and early electrical control was based on relays. These relays allow power to be switched on and off without a mechanical switch. It is common to use relays to make simple logical control decisions. The development of low-cost computer has brought the most recent revolution, the Programmable Logic Controller, PLC. The advent of the PLC began in the 1970s, and has become the most common choice for manufacturing controls. Many PLC configurations are available, even from a single vendor. But, in each of these there are common components and concepts. The most essential components are: power supply. This can be built into the PLC or be an external unit. Common voltage levels required by the PLC, with and without the power supply, are 20-volt voltage, 120-volt voltage, 220-volt voltage. CPU, Central Processing Unit. This is a computer where ladder logic is stored and processed. I/O, input and output. A number of input and output terminals must be provided so that the PLC can monitor the process and initiate actions. Indicator lights, these indicate the status of the PLC including power on, program running, and a fault. These are essential when diagnosing problems. Inputs to, and outputs from PLC are necessary to monitor and control a process. Both inputs and outputs can be categorized into two basic types, logical or continuous. Consider the example of a light bulb. If it can only be turned on or off, it is logical control. If the light can be dimmed to different levels, it is continuous. Continuous values seem more intuitive, but logical values are preferred because they allow more certainty, and simplify control. As a result, most controls applications, and PLCs, use logical inputs and outputs for most applications. Outputs to actuators allow a PLC to cause something to happen in a process. A short list of popular actuators is given below in order of relative popularity. Solenoid valves, logical outputs that can switch a hydraulic or pneumatic flow. Lights, logical outputs that can often be powered directly from PLC output boards. Motor starters, motors often draw a large amount of current when started, so they require motor starters, which are basically large relays. Servo motors, a continuous output from the PLC can command a variable speed or position. Outputs from PLCs are often relays, but they can also be solid-state electronics such as transistors for DC outputs or triacs for AC outputs. Continuous outputs require special output cards with digital to analog converters. Inputs come from sensors that translate physical phenomena into electrical signals. Typical examples of sensors are listed below in relative order of popularity. Proximity switches use inductance, capacitance, or light to detect an object logically. Switches, mechanical mechanisms will open or close electrical contacts for a logical signal. Potentiometer measures angular positions continuously, using resistance. LVDT, linear variable differential transformer, measures linear displacement continuously using magnetic coupling. Inputs for a PLC come in a few basic varieties, the simplest are AC and DC inputs. Sourcing and sinking inputs are also popular. This output method dictates that a device does not supply any power. Instead, the device only switches current on or off, like a simple switch. Summary: PLC stands for Programmable Logic Controller. A PLC is a computer-based controller that uses inputs to monitor a process, and uses outputs to control a process using a program. PLC has three basic parts: power supply, CPU as well as memory, input and outputs modules. Outputs examples: actuators such as solenoid valve and motors, lamps, and relays. Inputs examples: toggle switches, proximity sensors, and potentiometer. Thank you for watching our first video on PLC. We hope that you will continue being with us. Please subscribe to this channel and like, comment and share this video. Stay safe.